Hello students. The question says it is known that 1.2% of the rods made by a certain machine are bent. The random variable x denotes the number of bent rods in a random sample of 400 rods. The first part of the question says the distribution of x. Now, since the events are independent and this is the probability value which is given that the rods are bent, so we know that the value of n is given as 400 and the probability is not changing with the events like they are independent. So the probability value is 0.012. So the distribution has to be binomial in this case. If I move on to the second part of the question, they say state with a reason suitable approximate distribution for x. Now, if I'm approximating the distribution for x, so since n here is 400, which is greater than 50, so we can say that n is large. On the other hand, the value of mean, which is n into p, that means 400 into 0.012, which is equals to 4.8 is less than 5. So if the value of n into p is less than 5, we can say that the probability value is very small. So assuming these two assumptions over here to be correct, so we can approximate it as a Poisson distribution. Now moving to the third part of the question, it says that use your approximation to distribution to find the probability that sample will include more than 2 bent rods. So if I'm going for part 3, they have asked for px greater than 2. So that means we have to calculate 1 minus the probability of 0 plus 1 plus 2. So we'll use the Poisson distribution formula. P of x equals to e to the power minus lambda into lambda to the power x divided by x factorial. So the value of lambda that we have already found out over here is n into p, which is 4.8. So we'll use the same form over here. So if I'm writing 1 minus, I'm calculating it for p0. So e to the power minus 4.8 into 4.8 to the power 0 divided by 0 factorial plus e to the power minus 4.8 into 4.8 to the power 1 divided by 1 factorial plus e to the power minus 4.8 into 4.8 whole square divided by 2 factorial. So if I calculate this value, so the answer for the second part of the question is, third part of the question is 0.857. That's the answer for the third part. Thank you, students.